Hello and hi everyone. For Mathematics 183 video presentation, we as members of Group 8 from Group 15 are going to present about the applications of differentiation. First and foremost, what is differentiation? So differentiation is a process of finding a function that outputs the rate of change of one variable with respect to another variable. Now we know that the applications of differentiation can be used to find related rates. So what is related rates? Related rates are the rate of change associated with two or more related quantities that are changing over time. So for example, we want to find the rate of change in spherical ball that being filled with air, and both of the radius and the volume of the ball are increasing. Therefore, the rate of change in volume is related to the rate of change in radius. In this case, dV over dt and dr over dt are related rates because V is related to R. To find the related rate, we must know some formulas. As you can see here, different solid figure has different area and volume. Therefore, here I attach some formulas of area and volume.
Hi, my name is Kailesh Lee and I will continue with problem statement. Gravel is being dumped from a conveyor belt at a rate of 100 feet cubic per minute to form a conical pile, whose base diameter is 2 times the altitude. How fast is the height changing when the pile is 12 feet high? When the gravel is dumped into the conical pile, we know that the pile is increased in value. So, how could we know how fast is the height changing? So let's check to the next slide. First, we know that 100 cubic feet per minute is represent dV over dt, and we know the current height is 12 feet high, and the goal that we need to find is dH over dt. So we start to store the volume of the cone, which is 1 over 3 pi r square h. Next, we need to get rid of the r and replace with h. There's a sentence that states the diameter is 2 times the altitude, so d is equal with 2h. D can also equal with 2r, so 2r is equal with 2h. So we can see the radius is equal with the height. Therefore, we can replace the r with h, so it will become 1 over 3 pi h in the third power. And now we can differentiate to dV over dH, which is 1 over 3 times pi, then times with the derivative to the h, the third power, which is 3h squared. Cancel 3 and we get pi h squared. Last step, we can calculate dH over dt, which is 100 is dV over dt, times with 1 over pi 12 square, and we get 100 times with 1 over 144 pi, and finally the answer is 25 over 36 pi.
Let's rediscuss another one question. Water is leaking from a tank at a rate of 4 cm³ per second. The volume of water in the tank is given by V equal to 3x squared plus 24x divided by 2, where x is the height of water in the container. Question wants us to find the rate of change at which the height of water is decreasing when the volume is 30 cm³. For the solution, let's proceed to the next slide. From the question, the information that we'll get is dV over dt is equal to -4 cm³ per second. Why negative? Because the question stated that water is decreasing. dx over dt is the rate that we want to find when the volume is 30 cm³. First step, to find the dx over dt is equal to dx over dv multiplied by dv over dt. From the question also, the volume given is 3x squared plus 24x divided by 2. Then we simplify the equations of volume, we will get 3 over 2x squared plus 12x. Now we differentiate the volume to get dv over dx, which is 3x plus 12. After that, substitute dv over dt into the equation dx over dt. However, we don't have dx over dv, but we have dv over dx. Then we flip the equation. Dx over dt, we will get 1 over 3x plus 12 multiplied by negative 4. Then we will get negative 4 over 3x plus 12. To find the height of water decreasing, what we need to do is 3x squared plus 24x divided by 2 equal to 30. 30 multiplied by 2, then we get 60. Bring 60 to the left. Simplify the equation, then we will get x equal to 2 and x equal to negative 10. But since we want to find the height of water, then we use x equal to 2. At the end, we can find the rate of change.
Now we have concluded in differential calculus related rates problem involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate of change is also usually with respect to time. Therefore, here is some steps that we have concluded in doing related rates problem. Firstly, draw a diagram to have visualized the problem if possible. Second, express the given rate such as look for units with time in denominator. Third, express the asking rate as look for phrases such as how fast, at what rate, and find the rate. Fourth, write an equation that relates the various quantities of the problem. Fifth, differentiate both sides of the equation with respect to the time. Lastly, substitute the given information into the differential equation and solve for the asking rate. That is all of the steps, and we have pretty much covered some relevant questions for calculus-related rates. Of course, there are many other questions for related rates calculus. However, as long as you follow the 6 steps, you should be able to do.
That is the end of our video presentation. Thank you for watching, and we do hope that you will enjoy our video presentation and also you will measure this subtopic. So I guess till we meet again, and bye bye.